Hello everyone. In this video, I am going to explain Mohr Coulomb theory. According to Mohr, the failure is caused by a critical combination of normal and shear stresses. The failure is identified by the slippage of the soil particles. The soil fails when the shear stress on the failure plane is unique function of the normal stress acting on that plane. So he gave the equation, that is tau is equal to f of sigma. That means shear stress is the function of normal stress. But shear stress on the failure plane at failure is defined as the shear strength. Hence the above equation becomes S equal to f of sigma. Using the above equation, a plot can be made between shear stress and normal stress at failure, and the curve so obtained is called Mohr envelope. Means for different combination of major and minor principal stress, we will get different value of shear stress and normal stress at failure. And if we plot this value on a graph, we will get a curve line. This curve line is called Mohr envelope. And there is unique failure envelope for each material. The Mohr circle and failure envelope is tangential to Mohr circle. Failure of the material occurs when the Mohr circle touches the failure envelope. So here failure envelope is touching Mohr circle at point D. At the point of contact of the failure envelope and the Mohr circle, the critical combination of normal stress and shear stress is reached and the failure occurs. Any Mohr circles which does not cross the failure envelope and lies below the envelope represents a stable condition. Here point A lies within the Mohr circle. Hence it is stable, means at that point failure would not occur. The Mohr circle cannot cross the envelope as the failure would have already occurred as soon as the Mohr circle touches the Mohr failure envelope. So here is the point E which lies above the failure envelope. But the failure will occur at the failure envelope. So it is impossible to reach the value of shear stress beyond the failure envelope. Hence failure at point E is not possible. The shear strength of the soil at a point on a particular plane was expressed by Coulomb as a linear function of normal stress on the plane as S is equal to C plus sigma tan phi. Here C is known as cohesion, sigma is known as normal stress, and phi is the angle of internal friction. In other words, the Mohr envelope is replaced by a straight line by Coulomb. So, as suggested by Mohr, the failure envelope was curved, but equation given by the Mohr is linear equations. Hence, he replaced the curved surface of or curved line of failure envelope by a straight line. Later, research showed that the parameters C and phi are not fundamental properties of soil, as it was originally assumed by the Coulomb. These parameters depends upon a number of factors such as water content, drainage condition, condition of testing, etc. Terzaghi established that the normal stress which control the shear strength of the soil are the effective stresses and not the total stresses. Thus, the above equation can be written as S is equal to C dash plus sigma bar tan phi dash, where C dash and phi dash are the cohesion intercept and angle of shearing resistance in terms of effective stresses respectively. This equation is known as revised Mohr Coulomb equation. The Mohr Coulomb theory shows a good agreement with the observed failure in the field and in the laboratory. However, it has following limitations. First, it neglects the effect of intermediate principal stress. Second drawback is it approximates the curved failure envelope by a straight line which does not give the correct results. When the Mohr envelope is curved, the actual obliquity of failure plane is slightly smaller than the maximum obliquity. Therefore, the angle of failure plane as found is not correct. And fourth limitation is for some clay soils, there is no fixed relationship between the normal and the shear stress on the plane of failure. The theory cannot be used for such kind of soils. Thank you.